All right, let's get started with Chapter 6, Module 21. This is the final module in Chapter 6, and it's a fairly short one. Okay, so this one is on community succession. It is something you guys have already explored when we did the poster projects earlier. Succession is basically talking about and explaining how communities form, how either they form from nothing or how they form from previous communities that may be less complex. So we're going to talk about that. We're going to talk about primary succession, which is coming from nothing, secondary succession, how it happens in the water with aquatic succession, and then talk about different factors that determine the species richness of a community. So primary succession starts with absolutely no soil. You've got nothing around, you've got rocks, basically what you've got there. Virtually every community experiences ecological succession at some point. And so this is the predictable replacement of one group of species by another group of species over time. So if we look at primary succession, you can see here, this is a nice visual of over time what a forest ecosystem may look like. So primary succession is ecological succession occurring on surfaces that are devoid of soil initially. Early arriving plants and algae, as you can see here, maybe even lichens or mosses, all right, will start to come in and colonize bare rock and begin to form soil. This may come in from spores. Spores may just come and attach themselves to rock. This is a very resilient stuff that comes in from other places, may come in by wind, may come in by rain, and it just forms on these initially bare exposed rocks, all right? These eventually will begin to form soil as they die, as they trap maybe dirt and stuff that's flying in from other places. They'll start to form soils that will have small amounts of nutrients. This will end up giving you like annual wildflowers, which then that will provide all of this. What it's doing is it's providing deeper and more nutrient packed soil, which then leads to more resilient plants coming in, like perennial wildflowers and grasses. Of course, that makes your soil even deeper, even richer, which will lead to smaller plants like shrubs. Finally, not finally, but next you'll have trees, young pine forest, and finally you have the large growth forest. So this is how maybe a forest ecosystem would end up evolving from nothing during primary succession. And this, of course, then once you have these different types of plants in the area, different animals can live. There are some smaller animals that will even be able just to live in the lichens and mosses as their food source. And of course, large animals once you get the trees in there. Secondary succession happens, it's the succession of plant life that occurs in areas that have been disturbed but have not lost their soil. Something came in, maybe a disease, maybe a predator, maybe a wildfire comes in. Wildfires are a huge cause of secondary succession, kills a lot of the plants in the area, and then they go through the same process. You just don't have the bare rocks anymore. You'll start at an earlier stage. You may start here with the annual wildflowers. You may start here with the shrubs. It depends on what was destroyed in the event, or maybe it's even a long-term event that caused the decline of other species. So secondary succession occurs where soil is already present, but all the plants have been removed. Early arriving plants set these areas on a path of secondary succession. And this is kind of cool because depending on if the climate has changed since the original one was there, you can have secondary succession bring in an entirely different ecosystem, entirely different types of plants than what was originally there. So this is kind of cool with secondary succession. You can also have succession in a variety of aquatic ecosystems. Here, for an example, is a lake where you might have an open water lake. What can happen over time is accumulating sediments. All right, you just have the open water. Over time, sediment may accumulate on the bottom from erosion, just from dirt moving. And over time, there'd be an increase in floating or submerged plants. So you're already changing the ecosystem here a little bit. And then over even more time, as more and more sediment accumulates inside of here, you'll end up filling that lake basin, which then can give you entire terrestrial ecosystem where your aquatic ecosystem was once, with just like a swampy center. And that's kind of how swamps have evolved over time. Now, you guys can probably, I just want to go back for a second. You see primary succession happen all the time. You think like, oh, it's something that only happens in forests or only happens like out in the wild. You guys see it all the time. I can guarantee you. You go outside, you find a sidewalk, you find your driveway, anything that has a crack in it. When dirt just kind of falls into there, and then you end up getting weeds that grow in there, and your parents are like, oh, you got to go out and pull all those weeds out, or, and it starts to look kind of bad in there or whatever. That's primary succession happening, because what you're doing is you're going from nothing. There was nothing there. You're capturing dirt inside there. Then you're capturing some nutrients, some spores, and then you end up capturing grass seeds and stuff inside there and weeds that end up growing out of those cracks into the surface. So yeah, you guys probably see primary succession all the time. So now how all these come in together is that we talked a lot before about species richness and biodiversity and why that's important. So the species richness and biodiversity of a community is influenced by many factors. It's influenced by where you are on the earth, closer to the equator versus further away, your latitude. How much time has been there, the size of the habitat, and then, of course, the distance from other communities. And that's where this theory at the end here comes in, the theory of island biogeography. And it's a theory that demonstrates the dual importance of habitat size and distance in determining species richness. So basically, I know that that's a lot of words, right? So basically what it's saying is that if you've got basically species, and let's say you have a mainland, right? And then you have an island off to the side, right? So as this distance between the mainland and the island, as it increases, the less diverse the island's geography is going to be. Also, the size of that island, the bigger it is, the more diverse it's going to be as well. So the island's area and the distance from the mainland, you want to be closer to the mainland, and it wants to be a larger area to increase the species richness. Species richness increases as the size of the habitat increase. So in this example right here that you're looking at with the graph, researchers counted the number of bird species that inhabited reed islands and Lake Valence in Hungary. As the island area increased, so they're looking at all the different islands and are plotting them here, right? You can see the different plots here, the different island areas. You can definitely see a distinction at the number of bird species as the island area gets bigger. And this can be big in doing conservation efforts. And if you see a species decline, protecting certain islands, maybe the bigger ones that have more importance. You can even see this in Sarasota, the Roberts Bay Rookery Islands. If you guys go out onto into Sarasota Bay from Marina Jack or whatever, and you keep going out, the Roberts Bay Rookery Islands are basically protected because they are home for a lot of different bird species, and they are very close to the mainland, of course, and they're not huge, but they do host a lot of bird species there, and it's important to protect them. So that's pretty much it for Chapter 6. Please let me know if you have any questions. Email me, text that Google Voice number that I sent out, whatever you need, and see you all in Chapter 7.